Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, so where's my speaker? Okay, here. I'm sorry. Um, let's see. Okay, great. So this is also continue for our last lesson on redox. We still not final because actually redox takes quite a long time to explain it one by one. Yeah, now after we know about reaction of about redox reaction, also we know about is disproportionation reaction, combustion reaction, so single replacement displacement reaction. Now we'll start to learn how to balance a redox reaction via half reaction method. So redox reaction that takes place in aqueous media often involve water, hydronium ions and hydroxide ions as reactants or products. And although the species are not oxidized or reduced, they do participate in chemical change in other ways. The equation representing this ratio are sometimes very difficult to balance by inspection. So systematic approach have been developed to assist with this process. And here's the things that you need to follow. Okay, they are quite long. We have 9 points here. So first, write the two health reactions representing the redox process. Two, balance all elements except for oxygen and hydrogen. Three, balance oxygen atoms by adding the water molecules. Four, balance hydrogen atoms by adding hydrogen ions. Five, balance charge by adding electrons. Six, if necessary, multiply each half reaction coefficient with the smallest possible integers to get equal numbers of electrons in each. 7. Add the balanced half reaction together and simplify by removing species that appear on both sides of the equations. 8 for reactions occurring in basic materials. Carry out these addition steps. Okay, A, B, C. And 9 finally check to see that both the number of atoms and total charges are balanced. Okay, this is a very long step. Let's dive into the example so you can see the things that's pointed out clearly. Okay, so yeah, please balance the redox reaction in the acidic solution. Okay, so dichromate ion and iron 2 react together to yield iron 3 and chromium 3 in acidic solution. So step 1, write the two half reactions. So we see that the one is the specimen that's oxidized is iron. Okay, iron 2 become iron 3 is oxidized, or it means this is the reducing agent. And the atom that undergoes reduction, it is actually chrome, right? This is chrome. So from dichromate ion becomes chromium 3, it is reduced. Okay, how much? Okay, I want you to find it yourself. So minus 2, 7 minus 14, minus 14 is 2, 12, 12, 2, 12 by 2, 6. Okay, plus 6, plus 6 will be plus 3. That is reduced, right? Step 2, balance all elements except oxygen and hydrogen. So yeah, actually here we only have oxygen, we have no hydrogen. Okay, so we are asked to balance the others. But actually we have nothing to do with the first one because one iron, nothing done here. But for the chrome, we have two chrome here, but we only have one chrome here. So we need to add the coefficient. We need to increase the coefficient too. Good job. We have done with the step 2. Now move to step 3, which balance oxygen atoms by adding the water molecules. Okay. For the first one, this is also already fine. Don't do anything to it. But for the second reaction, half reaction, I mean, yeah, we need to add the water specimen, right? So we need to add water, but how much? The how much thing, it depends on the oxygen. We have 7 oxygen here, it means that we need to have 7 water molecule. Now, balance hydrogen atoms by adding the hydrogen ions. Okay, because we have 14 hydrogen atoms here, we need to add 40 hydrogen ions here in the left side too. Okay, I'm sorry. Next, we are done with this step. So step 7, add the balance half reactions and cancel species that appear on both sides of the equation. So we just need to combine it, right? And then cancel it. We have okay. Oh, I'm sorry. Um, yeah. After this first, okay. Balance charge by adding electrons. Okay. So the iron half reaction, so total charge of +2 on one side and +3 on the other side. So what the number to neutralize it? Yes, 6 +2 times +3. Okay, so this actually is for this actually, I mean +6. Okay, but to neutralize this one, we need to add one electron in the right side. How about for this? Hmm? We have -2 this side. We have 14 plus 14. So this is +12. This is +6. Okay, +12 +6. We need to add 6 electrons this side. This one. And after that, we need to eliminate this electron by how? Multiplying this with 6. Good job. So we now can eliminate the electron. It's very easy, right? And we combine it, and this is the final reaction. And to confirm that the equation has been balanced, this is the table to show you. Good. You have done with this. Now to check your learning, that you need to do solve this by yourself. Okay, so far we have discussed many types of reaction, and now we'll enter the realm of stoichiometry. So reaction stoichiometry. Okay, so coefficients provide the relative numbers of chemical species, and it allows a quantitative assessment of the relationships between the amounts of substances consumed and produced by the reactions. And the quantitative relationship is known as the reaction stoichiometry, because stoichion means element and metron means measure in Greek words. So the use of balanced chemical equations for various stoichiometric application is what we learn in this topic. Okay, so for example, yeah, we have this. Okay, so balanced chemical equations are used in much the same fashion to determine the amount of one reactor required to react with a given amount of another reactor, or to yield a given amount of product, and so forth. And the coefficient in the balanced equation are used to derive stoichiometric factors that permit computation of the desired quantity. For example, we have this. We have nitrogen gas plus three hydrogen gas reacts to make a two ammonia gas, two molecule of ammonia gas, I mean. And this equation shows that ammonia molecules are produced from hydrogen molecules gas, okay, in a 2:3 ratio, okay, and the stoichiometric factor may be derived using any amount, okay. So it doesn't matter which amount or number unit that we use, but as long as the ratio still confirm, I mean, we still stick to this ratio, it's okay. Okay, so we can use 2:3 with the molecules, 2:3 with dozen molecules, 2:3 by mole molecules. It's the same things. Okay, it doesn't affect. Okay, and these stoichiometric factors can be used to compute the number of ammonia molecules produced from a given number of hydrogen molecules, or the number of hydrogen molecules required to produce a given number of ammonia molecules. Okay, to understand this concept clearly, let's dive into the example. Okay, so yeah, how many moles of iodine are required to react with 0.429 mole of aluminum according to the following equations? 2 aluminum plus 3 iodine to become 2 aluminum iodide. Okay, so referring to the balance, a chemical equation that stoichiometric fact relating the two substances of interest is 3 molecule of iodine by 2 mole of aluminum. Okay, so let's see, we expect to have 0.429 mole of aluminum, so we need 0.429 times 3 by 2. It means that we need 0.644 mole of iodine to have the result that we want. Now, to check your learning, to check your understanding, I want you to solve this problem. Next example. How many carbon dioxide molecules are produced when 0.75 mole of propane is combusted according to this equation? So we have, this is propane, okay, this is propane, this is 5 molecules of oxygen, this is 3 molecules of carbon dioxide, and this is 4 molecules of water. Okay, so we still follow the same approach from the previous examples, and yeah, do the absolute number of molecules requested, not the number of moles of molecules. Okay, so the balance equation, this has already balanced. You can check it if you are not sure about this equation. Okay, it shows that carbon dioxide is produced from propane in a 3.3/1 ratio. Okay, so 3 carbon dioxide comes from one propane. Okay, so 3 mole by 1 mole of carbon dioxide by propane. Okay, and using this stoichiometric factor, okay, so we have for 0.75 times 3 by 1 first. This is to know how much um, molecules of uh, no how much mole of this, what we are asked, oh, carbon dioxide, how many moles of carbon dioxide needed are produced, are produced. This is the result from this one. Okay, so we know first the moles of carbon dioxide, and later we also identify the number of molecules by multiplying with the Avogadro number, which is 6.022 times 10 to the power 23, and it gives us the result of approximately 1.4 times 10 to the 24 carbon dioxide molecules. And to check your understanding, you need to solve this. Okay, and yeah, the next one. What mass of sodium hydroxide would be required to produce 16 grams of the antacid milk of magnesia by the following reaction? So we have the okay, magnesium chloride plus 2 sodium hydroxide ion, a molecule, produce magnesium hydroxide plus 2 table salt molecule. Okay, so here's the flow chart that we need to follow to understand, to solve this problem. Sorry, and yeah, in this case, masses are provided and requested, so additional steps are the sort in the procedure required. Yeah, first times we need to find the moles of the magnesium hydroxide first, but it can only be done if we know, yeah, if we need to convert it first, right? Okay, so we need to know, uh I'm sorry. Mm, you see, the one that takes place is only these two, right? Mm, these two. The ratio is 2/1. Okay, the ratio is 2/1. But the one that we want to find is uh the hydroxide. So it is in the bottom part, right? On the upper part. Okay, this one. Okay, 2/1. 2/1. And this is used to know the moles of magnesium hydroxide because we have been given the information. So actually this is gram by the molar mass. So we know first how much mole is involved here, and later we just need to multiply it with, yeah, the respective molar mass of the natrium hydroxide to know how how much natrium hydroxide in gram that we need. And here's the process that we need to follow. And to check your learning, you need to solve this problem by yourself. Next, next examples, still with the same topic. Okay, so relating masses of reactors. What mass of oxygen gas from the air is consumed in the combustion of 7O2 of octane? Okay, so octane is this C8H18 of the principal components of gasoline. Okay, so 2 octane molecules plus 25 oxygen molecules yield 16 carbon dioxide molecules per 80 water molecules. Okay, so how to solve this? This is very simple. Okay, so first we need to convert the mass of the octane to the moles of octane first, and then we can by stoichiometric factor find the moles of oxygen, and then we need to multiply by the molar mass to know the mass of the oxygen. And by following it's actually identical to the previous example. And we get this result, which is 2.46 times 10 to the power of 3 gram oxygen, or 2.46 kilogram oxygen. Easy. And to check your understanding, I want you to solve this example. Okay, so after we have been pointing out with many kind of way to solve the stoichiometric reaction, finally we are pointing out the summary. Okay, so here's the point 10. Okay, general outline of stoichiometry calculations. Okay, so this is the summary, actually the flowchart summary. So you see, if we are given volume of pure substance A and density, okay, mass of A, okay, we have molar mass, it can be used with moles of A, volume of solution A, is molarity, okay, is the relationship, okay, number of particles A, it connects with mole with Avogadro number, most of one to most of other is connected with stoichiometric factor, most of B and number of particles is connected by Avogadro number. Okay, moles per volume is connected with molarity, mass mole is by molar mass, yeah, volume and mass is by density. Yeah, I think it's enough for this one. I will not make it very long. Before I end it, I want you to read this. I want to share a very good quote for you today. So believe you can, and you're halfway there. That's by Theodore Roosevelt. Okay. That's the end of the video for today. Thanks for watching, thanks for following so far, and here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with exploits.unaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you on the next episode.